Before we solve any equations, let's practice converting between exponential and logarithmic forms. Here we have three statements, three equations, written in logarithmic form. Let's remember how to read this. The value of x is the exponent to which we raise the base b to give us the value y. We can say that the base b is raised to the exponent x, and this gives us the number y. Let's try that. The logarithm of 121 to the base 11 is equal to 2. What this means, in other words, is the base 11, when raised to the power of 2, gives us 121. 11 raised to the power of 2 is equal to 121. Is that true? Absolutely. 11 squared really is equal to 121. So we've done this correctly. Let's try two more. Here we have the logarithm of 1 over 36 to the base 6. We're told that's equal to negative 2. Start. In other words, 6 raised to the power of negative 2, 6 raised to the power of negative 2 is equal to 1 over 36. Is that correct? Absolutely. 6 raised to the power of negative 2 is equal to 1 over 6 squared, and 1 over 6 squared is 1 over 36. And finally, the logarithm of 16 to the base 8 is equal to 4/3. We can write this as 8 raised to the power of 4/3 is equal to 16. Or 8 raised to the power of 4/3 is equal to 16. What about the other way? Sometimes it's easiest to rewrite exponential forms in logarithmic form if we label the components. So 5 here is our base, and the base of the exponent will become the base of the logarithm. The exponent is always x. The base is raised to the value of x. So we have the exponent x down here, and we'll see that the logarithm is equal to x. The base raised to the exponent x is equal to y. In the logarithmic form, y is the number we take the logarithm of. So the logarithm here is of 125 to the base 5, and that's equal to 3. Sometimes reading it back to yourself, or rather converting logarithmic form back to exponential form, can help check whether you've done this correctly. We read the logarithm of 125 to the base 5 equals 3 as 5 raised to what power gives us 125? Well, 5 raised to the power of 3 gives 125, which we know to be true. Let's try the second one. Once again, 81 is the base. The exponent is the value of x, and the answer of b to the power of x gives us our y value. When we write this as a logarithm, since the base is 81, the base of our exponent is 81, the base of our logarithm is 81. We take the logarithm of y, in this case 27, and that's equal to x, or 3/4. To read this, we see that 81 raised to the power of 3 over 4 gives us 27. And finally, here we have the base of 3 raised to the exponent of negative 2, and we're told that's equal to 1 over 9, the value for y. In other words, the logarithm of 1 over 9 to the base 3 is equal to negative 2. Or 3 raised to what power? Well, 3 raised to the power of negative 2 gives 1 over 9.